come off mute to ask a question or something like that. Great. Well, welcome everybody. This is a talk that's intended to help you think about how you would add AI to your existing .NET apps. A couple of key points there that you have something that already exists, you want to add some AI to it, and it's in .NET, C#. It's kind of a platform that you're accustomed to. Maybe you don't want to go convert to Python into the AI world, and that's entirely realistic using some of the tools and technologies that we'll kick around today. So I'm Bill Wilder, and Jason Haley will. I'll start the talk. I'll do the first part, and then Jason Haley will come on and wrap it up. We're going to try to get done by the 1 o'clock end time because people are at work. So welcome again. My talk is going to focus on goal-oriented AI. It's kind of what an agent is considered. I'm going to just focus on the fact that I'm not going to talk about all the facets of building an agent, but the heart of it is essentially you're giving your AI a goal rather than telling it what to do step by step. I think you've all seen the chatbot demos, or you've used ChatGPT and so forth. Fantastic use case in a lot of scenarios, but this is a step up in power. And I'm going to do my demonstration in C# in a console app using Semantic Kernel. And I'll have a slide at the end where I show where I'll post things, but so you can get access to the slides and the code later. I'm assuming that you're all aware of the LLM stuff. You've used ChatGPT, an LLM is a large language model, and that the language of interacting with these LLMs is prompts, and this concept of prompt engineering to get stuff done. That's actually going to be the heart of this talk. We're not going to do any prompt engineering, or we're not going to write prompts live, but the point of this talk is that prompts in and of themselves, if they're configured in the way that I'm going to show you, can be very powerful because you can give your AI a goal that is a prompt and say, go figure this out, and we'll explain how. I'm assuming you know what a token is, or at least vaguely aware that AIs have token limits. You can't send an AI everything. You have to be thoughtful. Both what you send it and what it sends back are limited, and you pay for tokens. This is the unit of a cost that shows up in your bill substantially. Large language models, it's AI. You kind of know what that is. And I'm assuming everybody knows what a chatbot is, so we're trying to look beyond the chatbot. Okay, so let's jump into giving your AI a goal. I'm gonna just show you a prompt. I get a valid URL for the logo of insert brand here. Show a reference to it in an HTML image tag. Make it concise, and show a description of the logo. Not that it's the logo for the Python project, but what does that logo look like in the title text? And the alt would say logo of Python or something like that. So this is a simple prompt. How do we take a prompt like this and make it more robust, more automatable, and so forth? That's going to be the heart of this talk. So before we go further into the slides, I'm going to jump over to some code for a minute. So I have a simple console app here, and you're going to see I have, basically I have the ones we care about here are program.cs and image URL validator. I'm going to just show you how this works. I'm going to run this .NET run. That's how you run a console app. Not going to work. And that's because I have to set some environment variables. Just trying to remove a little bit of the voodoo here so you know what I'm doing. I'm going to source this file. and it sets some environment variables. Now, if I try and run this again, it runs successfully, but it gives me a usage error. So I'm gonna now this is the real use. I can give it a technology brand like the Python programming language or .NET or Rust or something else. If you have one you want me to try later, stick it in the chat. But I'm gonna hit .NET run Python, and let's see what happens. Okay, so let's unpack what has shown up on the screen here. I see a comment with asterisks. That's going to be relevant. I'll show you that in the code. But basically, that is a, a, a debug statement from the logic that validates that the URL is resolvable. Then there's one with hashes, and that is a debug statement from some from a function. I'll use the right terms here. That is trying to figure out what the logo looks like. This is a URL to the logo, and this is a description of the logo, and it came up with this description. The check mark is intended to tell you that it worked. It doesn't always work though. The image, and this is the output that the second function derived. The image shows the Python programming language logo. It features two intertwining snakes, one blue, one yellow, alongside the word Python in gray font. So this just came from the AI because I gave it a logo to look at and asked it to describe it. And then in the font that you saw earlier, I mean, so the high level prompt that I showed you, the goal that we gave to our AI was to produce this image tag, and here it is. So the title is a description, as we asked, and that was achieved by calling this function up here, the hash function, on the logo found by the asterisk function. And then it says alt equals Python logo. So we're done. That was pretty successful. I'm going to run it again. One thing about large language models is they are non-deterministic, meaning that if you run it 2 times in a row with exactly the same inputs, the output is not guaranteed to be the same. And you can tell here already that this HTML block is different than this one. So even just the wording is different. This is comma gray font, and this is in a gray font. Written in lowercase. I don't think it says anything about the casing of the text up here. So we're not going to examine that in detail, but just making you aware that that is a difference in the output because large language models are non-deterministic. That sometimes makes prompt engineering a bit of an art because you're trying to come up with you're trying to convince the AI to produce good output all the time, even though it's not the same output. So testing is different, for example, in a world with LLMs. Let's run this a third time. Okay, this one's going to be too successful. I'm going to switch. I'm going to try the programming language Golang, the Go programming language. Let's see what happens. And by the way, a non-deterministic LLM also makes it difficult to demo sometimes because it doesn't always go as you wish. And let me try. Let's go with Rust. Trying to do is I'm trying to get one to fail because sometimes it fails. Okay, so I'm going to make one up. I'm going to go with Sandworm, which is the name of a cybersecurity outfit in Russia. That's the code name assigned to them. And you're seeing you're getting different kinds of outputs here. We go back up here, we see that it's trying to, we got the asterisk. This is trying to validate that the URL exists. Actually, let me go up here for a second and show you with this Rust logo over here on the right. That's the logo that it was checking out. Try this one here for Go. That's the Go logo. Okay, that's cool. And let There's a Python logo. Okay, those are all cool. Now let's look at the logos that we're being asked to check out for a Sandworm technology project. And 404. And these are clearly wrong for those of you who read internet standards. The example.com domain is explicitly reserved for examples that nobody can own or that, so it'll never resolve ever, and so forth. So these are all didn't resolve. Even though a page came back here, it still detected that it didn't work. So so we're helping the LLM here. Java. Let's go into some code. I'm gonna let that run. And actually, this is good. One of the Java ones failed. Let's look at that. Or whatever that is. So it came up with one. The checker, asterisk guy, validly said, hey, that failed. That there was no URL there. So it said, it returned an internally returned an error. We'll look, this is the code we're going to look at. Note that the tries are out of order here, interestingly. It counts how many tries there are. Oh, I'm sorry, no, the tries aren't out of order, my mistake. But interestingly, the LLM tried 3 times. It tried 3 different URLs before picking one and putting it in the output here. Let's see what it came up with for output. That's fine. That's a standard Java logo. Blue cup of coffee with the word Java. So let's go to the code. And see what what kind of code we had to write to make this this kind of agent-like behavior able to happen. Okay. Pop back here for a second. Nope. There we go. So here is VS Code, and these are the same files we saw from the command line. And we're really going to look at just a couple of files. We're going to start with program.cs. This is a standard console app. You do .NET new console, and this is what you get. And then I added stuff to it. So I'm going to just quickly thumb through this so you can know what I've done. Some using directives of the semantic kernel NuGet packages, pretty standard stuff. Some chat completion, and in connectors to this program has the ability to talk to OpenAI directly or go to Azure OpenAI. The underlying model is the same, except one's hosted by Microsoft, one's hosted by OpenAI. Standard logging stuff for .NET. This is a class that I wrote that simply gets variables from the environment. And you saw those when I ran the source command, and just outputs. These are the environment variables that it's set, so that I don't have to have keys in my code. There are certainly other ways of doing that, but this is one that's friendly to this demo I'm given for multiple reasons. You'll see it's also relevant when I'm in the prompty file that we'll get to. That's just local code. And this local code is called the code I just showed in the environment readers to load these values. Environment variable reader, get these environment variable values for OpenAI, and there's one get them Azure OpenAI and one for OpenAI. So again, I'm just trying to show you that this isn't not much voodoo going on here. Command line, grab the command line. If there's a command line, just concatenate it all together into one token. And then now we get into the, so this is still generic dependency injection stuff for console apps. And now we're getting into the semantic kernel stuff at line 38. Not very interesting. Got completion service created here. Oh, I'm sorry. This is falsed out. My bad. I'm not reading this clearly. but this is not. This is in Azure. Add an Azure OpenAI chat completion object or service to the kernel. Build the kernel. Standard stuff. Ignore. And then we have a few lines here. These are important. We're creating functions. This is the terminology that we use in Semantic Kernel, and other AIs use this terminology too. A function is code or prompt logic that exists in your app or agent that the AI can call. This is not you calling the AI with a prompt. This is the AI calling you. And this is where the power lies. This is how you give your AI goals. And we'll look at the three of these. We have an AI with 3 features, 3 functions implemented. One as a prompt. One as this is the asterisk one, and this is the hash one, where this one finds the prompt. I'm sorry, finds the icon URL, like to the Python programming language, was the official icon. It takes a crack at it. In case it gives us a bad one, like we saw, there were cases where for say Java, we got some bad ones. This one tries to resolve it. Is it really something there? If there's not something there, this function just says, hey, it was a 404 error or some other error. So don't use this one. And then like we saw, the AI tried multiple of these in the Java example that at least one of them failed. And then it took one of the successful ones and it passed it to this, the image describer one, hashtag comments, and it said that it's it's a coffee cup with it's blue and whatever. And then the AI at the top level, the one that's calling your functions, then assembled that stuff together and output the HTML that we saw. There are some just attributes here, some metadata that you're sending in about it that matter. How many tokens do we want? This is a challenge to get this exactly right, but you want enough tokens, but you don't want to waste tokens. We don't really going to talk about that other than to say that it's an important part of this. I guess let's say if we made this 50 tokens and we ran this again, it's not going to go as well. Come on. And I'm not sure what's going on there. Let me just run it again. What I expect to happen is that it will run, but give a substandard response. Not sure why. So that this is an unusual behavior, but let me boost this back up to 3,000 and make sure that everything still works.
Yeah, you may not have had enough tokens to even get the response or request out.
Oh, maybe I should have made it a little bigger. Okay, so it's back running again. It looks like one. Oh, I'm rate limited. Oh, uh-oh. So let me bring it back down to 2,000. That'd be okay. All right, I'm gonna let my rate limit roll over to the next minute, and I think I'll be okay. But let's keep going through here. So I could use so this is false, this is true. So this is the prompt that we're dealing with. Get a valid URL for the logo of substitute brand, and Python, Java, we're trying a technology brand, and ideally it's the one published by the org, not one Bill created. Show a reference of it. So this is what we saw this in a slide earlier. And that's most of it, except I want to emphasize this one line here, that along with the functions I describe above here in the plugins region, this is a behavior that you specify to the LLM that it should automatically choose the functions that it calls. So given the prompt that we gave it, it's going to figure out, well, how do I get a valid URL for a logo? And it looks at the options, well, and then it picks one and calls it. And then based on the answer, it might call it again, because that's what happens with the icon finder. If it gets one that's valid, it might call the URL validator, and it says it's not valid, so it calls it again, keeps trying. Let's look at those three. And the icon finder is this prompty file, and basically this is a YAML file. This is what's called prompty. There's a whole plugin for this. You can actually run this plugin independently, and it gets you Python logo. Run it again. Get you the same Python logo, and you keep running it. You could give it Java and run it, and it works pretty well. So it's just you can test this independently of running it in the overall application, which is pretty handy. But it has a big prompt here that says you're UI assistant. Your job is to find logos for software technology brands. And this is basically just this file. That's it, is the whole function for Logo Finder. So where's it getting its data from? Getting it from its training set. The AI innately knows this. So if you want to do it on something that was released last month, it's not going to work because it doesn't have it in its training data. But that's a limitation. Jason talks about RAG a lot. You could use RAG to improve life there, but it still works. Let's go over to, let's look at one more of these. We'll look at the image validator, and this is the comment I mentioned, standard C# stuff, standard console app stuff, where it's just C#, just using the HTTP client and trying to call the guy. Can I resolve this URL? And if I can, if it claims to be is it the right file, or is it is it a BMP file? Or if it's a ping file, does it have the magic number at the top, and so forth. So there's a few reasons it could fail, but this basically just returns, if it's successful, it writes success and returns true, otherwise it returns false. And the AI driver, the LLM, based on that simple prompt, figures out what to do and who to call. There's also one for the image describer, which uses the OpenAI LLM directly, doesn't use the Azure OpenAI. It gives it the image. The image comes back as a description, but I'm not going to show that. I'm running a little low on time. That's it. Let me. Okay. So let me go back. C#. Actually, do C++. Old school. I don't even know if C++ has a logo. And I'm going to go back to slides to wrap up. It found one, but it didn't resolve, I guess. Well, let's go back to the slides and wrap this up. So I showed you the prompty one, icon finder, just some text. A YAML file was sufficient to implement that function, that semantic kernel function. This one we looked at, it does HTTP client stuff and gets out of Dodge if there's any problem. The yellow stuff here, the highlighted yellow stuff, is what the LLM has to go by to decide when to call this function. So it knows that there's a function called validate URL. You know, notice that's different than this, different than the actual C# name of the function. It has a description tag for what this function does. Should really be focused on why the LLM would call this. And it has a parameter called image URL. And it knows the return type too. I should highlight that, I guess. The describe an image one, similarly, describe image at URL is the function name as far as semantic kernel goes. Return a concise text description of the image, and so forth. This was the little voodoo to get the this is the prompt and the and how to structure the call so that the LLM can create the text description of the image itself. And takeaways, the basic agent. You know, for an agent, you want to give it a job and have it do the job. And if you have an existing .NET app, this is kind of natural to integrate. It uses standard .NET stuff, NuGet packages, C#, plays nice with a dependency injection, so it's idiomatic .NET. LLMs are in the cloud. You don't need to choose one up front, and the integration is fairly straightforward. And there are other tools we could talk about if you're in this ecosystem with Azure OpenAI, such as AI safety, but well, that's for another day. I'm going to stick this on my blog if you want to get it, and I'll put the slide and a link to the code there, and hope to see you at other events. I'm going to turn it right over to Jason.
Okay, let me share my screen. Share. Can you see my screen, Bill?
Yes.
Good. Cool. All right. So I'm going to look at things a little slightly different view of adding AI stuff to your applications. So what I wanted to do first is to highlight some of the features that you can utilize AI for if you're writing business applications or looking to extend applications. Things that are commonly, I should say, common features that AI is used for here. So data generation, that's something that you don't often see demos of, but if you need a test site populated with data that is not representative, or it's representative of production, but not production copied, it could be completely generated by an LLM. So that's completely doable. And if I have time, I'll show you a project that you can take a look at to get some inspiration from. Categorization, grouping, and identifying similarities of data. That's something else AI is really good at. Summarization. I mean, these most of what we're talking about here are language models, so they're really good at summarizing. So you can give it. If I have time, I will show you an eSupport project that Microsoft has put together, and it does summarization of support tickets. So it will give a short summary of what is in the support ticket. But you could utilize summarization for if you have a transcribing service or a transcription of a video or something to summarize the video or the meaning. Another common usage. Unstructured data search, that's often called RAG. So that's typically where you can search for stuff that's in a PDF or a doc file, or if you have a scraper, you can pull HTML down, and your options are somewhat limitless there. But the RAG comes into play because it's retrieval augmented generation. Typically, you're doing not just search through a PDF, but you also want it to answer a question, as opposed to just find a place in a PDF. So semantic search is the basis of that, but then utilizing LLM to answer the question. Autocomplete is another thing. For any of you who are familiar with GitHub Copilot, auto-completing of code, that is definitely something that we're familiar with. And creating written drafts. So if I have time, like I mentioned eShopSupport, they do this for the support ticket. It'll generate a draft of what the support person could utilize to respond to the person who posted the support request. So these are all good features to utilize for AI. So let's take a look at some practical ways that this can be done. Smart components, again, this is a open source project by Microsoft as well. It's GitHub. I've got all the links at the end of this slide deck, so you don't have to worry about capturing them. But this is the GitHub repo. It basically has 3 controls. So one of them is a smart paste button, one of them is a text area, and one of them is a combo box. So this is the repo. Let me show you the code. And then it has a local embeddings library that we can utilize. So let's take a look at the code here, smart components. So I'm going to show you the Blazor version. So they have 2 flavors. One is Razor Pages, one is for Blazor. And let me get this started up here, and then we'll take a look at the code. So there's the smart paste button. So that is right here. So let's look at the code we'll just look at the mailing address. So the idea of this smart paste button is it will take what's on the clipboard and automatically fill out forms. So this demo shows like first name, last name, phone number, address. So a form that you would have that an end user would need to fill out. But the idea is that if they've got it on the clipboard or some of that information on the clipboard, that this button's smart enough to populate the form for you. So let's see how it does that. We will look at the demo, smart paste. Let's look at the email, or I should say the mail address. Now here's the button. It's just a component for Blazor. So let's grab this here. So this maybe this be content that was sent to you in an email, but you need to fill out a form on, say, an internal application where you're logging calls or something along those lines. So let me copy this to my clipboard and then hit smart paste. And it filled it out. So it filled out the information from that small sentence. And let's see how it did it, or let's see what it did do. So what it does on the back end, so I've put some console writing messages in the code so that we can see this, is it first grabbed the information about the form that it knows about, and then it grabbed the clipboard contents. The very first time you run this, you do have to let the browser have access to the clipboard. That, of course, is a browser thing. And then this is where the AI comes into play. So this is the prompt that went off to the LLM. And then this is the results that we end up getting. So it figured out that of the form, which values go where. So that's the smart paste button. This, maybe you can't use this feature, but the cool thing is this is an open source project so that you can go through this code and see how they tied all that together from a UI feature all the way through prompting an LLM to do some deciding or reasoning and then come back with information to then update UI. So let's look at another option. Let's look at the text area. So I mentioned one of the things that AI is good with is auto completion. So with this text area, let me show you the button here. So this is text area. Let's look at the basic example. So this is the Blazor component. It's just a smart text area component, but it has a user role and it has some user phrases that it utilizes for inspiration with the LLM to basically guess what the user is going to type next. So autocomplete. The role that this demo uses is an HR administrator replying to an employee inquiry. So think any of those demos that you've seen, like a RAG application where they're providing a persona to the LLM saying, you are an assistant that does X, Y, and Z. Think of that with this right here. So you're an HR administrator replying to an employee inquiry. So let's look at let's put this here and then grab the browser and say, okay, so this is an HR person replying to an employee. So let's see, did you finish your training? Question mark space. So see, it's going off to the LLM. It's trying to figure out what to type yet, and apparently it doesn't have a clue for what I'm typing here. But the sick policy can be found at. Okay, so it started to pick up where I'm going with this, and I put period, and then it should come up with something else. Full-time employees have 28 days. So it's starting to do autocomplete for me here. The really cool demo is this one. So if I go to C# completion and I start with var s equals this is a test. Start writing some code here. I gotta do a semicolon. And then it said, oh, console write line, console read line. So it's a lot like Copilot. I mean, granted, it's not going to be quite as good because we're going through an LLM that's general based, not code specific. But this is, really cool to look at. Look at the code. So you saw the request going through as I was typing. So think about this when you're implementing features with your applications, and if you need some sort of an autocomplete, this may be some code that you'd want to look at, or you could try using the component itself. So the last one I want to show you is a smart combo box. This we're not going to look at the component on this one. It's pretty simple. It's just doing a semantic search, and you may have heard that term, but behind the scenes it uses this technology called vector embeddings. And it is trying to find things by meaning versus just like a text search. So the expense category here, if I say, okay, I'm going to a conference, I'm going to need a hotel, but the word hotel is not a valid item in the expense category listing that it's filtering off of, but it recognized that travel is similar. So that's the idea of embeddings, so which takes us to this next demo. This is a library that they provide. It's a wrapper around a model out on Hugging Face, but it will run locally on your machine. You don't have to use OpenAI to make the API call to get the text embeddings. You can, but this provides similar functionality. So as I mentioned, it has to do with semantics. There's a lot. We could do a whole hour on just embeddings, but I'm going to generalize here a bit. Let's put some generally similar things together here. So some colors: blue, green, red, yellow, white. Now something different: house, barn, lake. So you can see lake, barn, blue. Oh, so let's try water. So water and lake are next to each other. Ocean. Ocean, water, and lake are grouped together. Blue, green, yellow, white are grouped together. House and red. So I'm not quite sure. So red barn, I guess red barn, that's a typical thing. So you can see the idea here. The semantically similar words are next to each other. And the way that these embedding models work, single words don't work great with them because they're really looking for a window of text to get a context and really steer the semantic meaning. Single words don't work awesome, but you can see it actually didn't do too bad of a job. So that is local embeddings, smart combo box, and smart paste, text area, combo box, and local embeddings. And that's the smart components project. So as you can see, what the functionality was, think about when you need to do something like that with your application, and the implementations may be something you could take some inspiration from. This next demo I have is it uses the AdventureWorks database. So this is an implementation of using Azure SQL with embeddings, utilizing the new vector support that's in public preview. This demo, I'm only going to show two things. One is the category listing as well as similar product functionality. So you think Amazon, you go and look at a product, it will list similar products below it. That type of functionality. So if you needed something similar for your application, this is one way that you could do it. So it's this here. So the idea was to utilize the sample database that Azure SQL provides. When you create a brand new Azure SQL database, you can choose either blank database or you can choose a sample database. So this is using the sample database. As you can see, we've got bike parts, we've got some clothing in here, we've got cleaner, we've got, like see, these are mainly bike parts, clothing, other things that are bike related. Here's the categories of the products that this database has, and they're all over the place. If you're building an application, typically you're going to want to order listings so that they logically are easier to find by people. And if you don't use AI, then you've got this problem that this alphabetized category list has. So you can see we have accessories, we have shorts, then we go into some bike related items, bikes, then we go to cages. So we've got caps, chains, cleaners. So logically, there's no order to these. So if I'm going to the site and I'm thinking I wanted to find some shorts for biking or whatever, then I might not think that shorts would be up at the top. If I scroll down, then shorts are down at the bottom because of S. So alphabetized, if I look for shorts, it would make sense. But if bib shorts was what I was looking for, they're actually the top. And I would kind of think that logically, those two would be next to each other. So look at this list. This is using the local embedding model that we saw in the last demo. That's what the local is in this demo. But I'm also showing the OpenAI's added to text embedding so that you can see they aren't the same. And they're not compatible. So what I use for one embedding model is not going to be the same for the other. It's just the functionality they provide is very similar. And when it comes to language, one's probably going to be better than the other. Like for instance, in this case, the OpenAI one's slightly better for the category listing that we have here. So if we look at accessories, components, bottom brackets, and then we go into shorts. So bib shorts and shorts are right next to each other in this listing. So logically, we've got shorts here, but the bottom brackets doesn't quite fit there. And logically, because that's a bike part. But if you look at the OpenAI, it's actually a bit better. So we've got things that you can wear up at the top, and then we get into bikes, types of bikes that they have, bike stands, handlebars, and then we get into bike parts. So this is another way that you can utilize AI. This is just using embeddings to group things logically. Now let's look at that similarity, using that idea that it'll group things that are similar together for a similar product listing. So let's look at some shorts. Let's go to, I should have put a short, okay, so here's women's mountain shorts. So unfortunately, the mountain shorts don't demo quite as well for this similar items as, say, the men's sports shorts. Mainly, I think it's because mountain is used in so many different products on this application. This similarity search that it's doing, so it's taking not just the product name, but the product category and the description to find other similar products. So what other things are grouped together? And you can see this has mountain in it as well as mountain. So I think mountain is throwing the clothing with the word mountain in it off. So let's look at sports shorts. Sports shorts are at least we have all clothing here. So we have bib shorts, mountain shorts, racing socks. This is a cap, and then gloves. So we have things that we can wear. So this, I've got two different embedding models showing here as well. This is the local one that I can run locally on this machine. This is the OpenAI one, so I have to actually call an API to generate these. So these are also all things that you can wear. But you, as you go through this demo, you can see that some things are it's doing really good on some similar items, but not all. It's not perfect, but it could really get you a lot of the way that you would need to come up with similar items without having to really do a lot of manual data work on the back end. So all I was using is just I embedded it. I ran everything through the embedding, and then all I'm doing on that site is showing the embeddings. So I will introduce the eShopSupport, but I'm not going to be able to dive into it too much. I do have a link to a video where Steven Sanderson, who I believe is the guy who created it, gives a whole hour about it. And I've noticed that it's also in some of the .NET Conf videos that are going on this week. So there's going to be some more recent videos, because this one that Steve did was earlier this year. I think it was around June or March maybe. But anyways, it, so I mentioned data generation is something that these LLMs are really good at, or a good use case for using LLM. He has a generator in there that does everything. So the application is a product support site, so people can propose problems. They can propose ideas for new products. They can say they have a problem with a product. So in order for a system to be written about that, you need products, you need product categories, you need some sample tickets, you need some sample conversations about those tickets, you need product manuals, and then he also has a search, so that he creates these product manuals. These multiple product manuals are all being generated with this data generator, and then translated from Markdown into PDFs, and then he does that RAG functionality. So this one project has the data generation. It has an example of doing categorization. Like if someone submits a question, it categorizes that ticket as a question, uh, and I'll show you this, but it does summarization, it does the unstructured search through PDFs, which is RAG. I guess these are two of the same things. It will generate some text for a response for the support person to reply to the person that submitted the request. And then, something else that you should really be aware of is an evaluator. So this will allow you to determine how well your system's doing. Is it really responding with responses that are accurate, or is it way off base? So let's take a quick look at this. I don't want to spend too much time on it because it is running out of time here. So another good reason to look at this is it's an Aspire app. So if you're new to Aspire and you want to find an open source application that is configured using it, this is all the pieces that are up and running with this one project. And this is the Aspire dashboard. So this is a great demo for you to get into. I'll show you the two parts here. This is the customer UI, which you have to log in. This is a use identity server, so username, password is Bob and Bob. This is a support ticket that I typed in earlier when I was just preparing. So I just typed it in and said, the light's not very bright with this flashlight. So let me go to the support side here. So for the staffing side, oops, link to support AdventureWorks, close, go to the I'll go to staff. This is the list of all the tickets. And these were all generated by the system, the generator that created the system data. This one is pretty interesting because it's actually in German, and I can ask it. And again, this is all code that you can dig into. So I can ask it, like, can you translate the ticket to English for me. Another thing that LLMs are really decent at is doing translation. So the user submitted it in German, but it will translate the English for me. So that is another cool thing. If I go back out, I'll just choose any one of them. There's a couple of buttons up here. What does the manual say about this? That's going to search the PDF. So that's the RAG functionality. And this is the drafting functionality. Write a suggested reply to this customer. So I type it, it does a little bit of research, kind of again, the RAG functionality of what is in the ticket, and it comes back with a possible response I could start with. So I use that for a reply, and then I have this draft that I can then modify from here. So again, all this is being done behind the scenes using AI. So I highly recommend checking out eShopSupport. It's out there on GitHub as well. So the last thing I want to show you is it's kind of a chat app for highlighting Semantic Kernel, Entity Framework, and Azure SQL, now that you can use vectors in SQL. So let me show you some of the pieces of it, and then this is the link. It's a hands-on lab, so you can do it yourself in your free time. So weekend's coming up here. So this is the one that ends in lab. So these are the tables. It's parses a PDF, and the document is going to be stored, or some information about the document is in the document table. Select star from document. So I've got 3 documents in this, and then the page is going to be the pages all chopped up into pieces. So here's all the pages for those 3 documents. I've got 9,000 pages in here. And then the page chunks are, I believe I have 500 token chunks with 100 token overlap. And then this shows the, so I say page chunk. This is all of the text of those page chunks and then the embeddings. So this is all stored in Azure SQL. And you can see here this embedding vector type. That's the new SQL or Azure SQL type that's available. So let me show you the code real quick. It's actually this one. This is the code. Actually, let me just show you the GitHub repo, because this is where the hands-on lab is. So if you go straight to the landing page, it gives you a little bit of information about what it is, just a little bit of background, and then what you're going to need, and then it walks through the steps. So the first thing you have to do is set up the database so that you have some place to store these vectors that we're going to store in there. And then the code, once you download the code, it's got a lot of starter code in it, but the steps are walking you through what that starter code is, and then taking chunks. It works out best if you've got GitHub open on one page, and then your Visual Studio or Visual Studio Code on another page or other window, because you can copy this and then paste it in. So it works best like you're building the code by what's in the walkthrough with the starter app. So the starter is only a portion of the end result. And so this is walking through how to, of course, you know how to do a connection string, how to enable the vector search, configuring the data context, and then building out the data context. And this piece here is the vector type. So this is new, and you can see it's 384 dimensions. If you're going to do OpenAI embedding, you're going to have to change that to the 1536. But this is using the local embeddings, and then this is also pointing that out. Then run the migrations. That's how you get the tables created, and then it walks you through some code that will chunk and parse the PDF and extract the text from the PDF. save it to the database as I showed you all those rows. So that's the first part is all geared toward getting the datas into the database. So configuring the database and then splitting the document into pieces and saving it into the database. So that's where the first half of this is. Then the second is a lot of what Bill was showing you with the semantic kernel and then being able to chat with that PDF, that implementation. That's what the second part of this is. So I highly recommend that you get your hands on this stuff and start playing around with it. So that's going to be a nice exercise for you to do this weekend. And that's really all I wanted to show. Is there any questions out there? We're about at time here. So Bill dropped a link to the survey in the chat for you.
We have a question here if you have a minute.
Yeah, absolutely.
So for different use cases, we set that temperature parameter, and I was wondering how you find a sweet spot for that based on your use case, and how you might change that if you're using a different approach, such as RAG, for your application.
Okay, so there are two pieces of the puzzle, or I should say two things that you would use for creativity, or how much variance you want back from the LLM. And the temperature is the top one that most people use. The higher the number, the more creative the response is going to be coming back, the less predictive it will be for you. So if you're using RAG, you're typically going to want that to be 0 to 0.2. So you're going to want it to not be very creative. You're going to want it to utilize the wording and the context that you're providing it, because you don't want it to start going off onto its own training set to be creative and open up the possibilities. The top P is the other one. I've heard that you can drive yourself crazy if you start modifying both. So play with one and try to get some improvement, and then try the other one to narrow things down. So the top P is the way that I think of top P is, say you're trying to do next word prediction and you have, say, 100 options for the next word. The smaller the smaller you make the top P, so say like 0.02 to or say 0, the smaller that option list is going to be. So you're going to get less, it's not really creativity, but you're going to get less variance in that case. So top P and temperature are the two. The smaller the number, the more realistic your response is going to be predictable. Does that
Understood.
make sense?
Thank you. Yeah, that makes sense.
Awesome. Yeah, good luck.
Appreciate it.
Any other questions out there? Awesome. All right. Well, I will. Do we have a final slide or anything to show, Bill? Oh, you're on mute.
I will reshare the upcoming stuff. Here we go. So
Sweet.
this is what's happening up and coming. I mentioned this before if you were joined, but this Saturday, join us at Boston Code Camp. There's a lot of stuff there, including AI. The first Friday of December, Jason, myself, and Juan Pablo from Microsoft are doing an in-person workshop in Burlington. The sign-up link is not yet out, but you can ping us through whatever means if you need to. But we'll get a sign-up form out on the meetup by the next few days, and then we're going to repeat that in January at Nerd Microsoft Cambridge building. And thank you for those of you who have willing to fill out the survey, give us some feedback. With that, I think I don't have anything else, Jason.
Nope, I'm good. Yeah, feel free to reach out if you have any questions.
Thank you. Thank you for come and spending your lunchtime with us.
Have a good weekend.
Thank you.
Thank you.
Thank you.
Thank you.
Awesome.